Here's a more complicated example as x is taken to infinity. Well, if you send x to infinity, this will become very, very large, and this will again become very, very large. So what you have here is infinity minus infinity. Well, then immediately you're going to wonder, what do you get if you take infinity and subtract infinity? Is it 0? Well, it turns out that this is one of those indeterminate forms. So to recall, we had learned all these indeterminate forms, right? 0 over 0 indeterminate was the one that we usually used for a lot of the limits when x is going to one point. And I forgot to say, but all these limit of a polynomial over polynomial, say 2x squared plus 1 over 3x squared plus 5x, if you have something like this, if you plug in infinity in top and the bottom, you get infinity over infinity. So when you have 0 divided by 0, infinity divided by infinity, or infinity minus infinity, because limits are basically sequence of numbers ever increasing, or it's getting closer and closer to something. If you have these forms, it really depends on which one is increasing faster. So the question here is this outpacing this by a lot? Then even if it's infinity minus infinity, it could be infinity. Or if this is almost same as that, you might get 0, but it could be just that this is only outpacing this by a little bit. And actually that's the case. You'll be surprised to find that this limit actually gives you a finite value. Okay. So I just want to note that this is an infinity minus infinity type indeterminate. And whenever you say indeterminate, that means this kind of analysis doesn't yield any answer. Okay, so if you had an equation like this, a question like this on the exam, and you just wrote down this, actually, because that doesn't really help, you don't get any partial credit. Okay. All right. So how do we approach this? Well, you have square roots, and often the trick was to, for square roots, you multiply by the conjugate, right? And the only problem is this is not a fraction. Usually we had fractions, so we were multiplying by the conjugate top and bottom. But here, it's not a fraction, so we're going to make it as a fraction. So we first think about this entire thing as this over 1. So now you can multiply by the conjugate so you take the sign between them and flip it. And the reason we multiply by the conjugate is because if we multiply a minus b times a plus b, there's this famous formula that says this times this gives you a squared minus b squared, right? And it's because of this. So you're going to get the first thing squared, which is x squared plus 4x. The second thing squared, which is just x squared plus 25. See, all the square roots are gone because you squared it. Now what's important is that you shouldn't forget this parenthesis. This parenthesis is okay to leave out, but the second one is crucial because without it you're going to make a mistake in the sign. So we have this, and then you divide by the bottom is x squared plus 4x plus square root of x squared plus 25 as limit x is taken to infinity. Now when you get rid of this parenthesis, this is x squared minus x squared, so luckily these two things cancel. Oh, that's nice. And then you have 4x minus 25 as the top, right? So you have limit 4x minus 25 over square root of x squared plus 4x plus square root of x squared plus 25. x going to infinity. Now, I think I'll need more room. This is rather complicated. So I'm going to rewrite this again. So we have simplified this into limit as x going to infinity of x 4x minus 25 divided by square root of x squared plus 4x plus square root of x squared plus 25. Now here comes the question. We were dividing by the highest power of the denominator so far, but what does that mean for us in this context? Well, the highest powers are x squared, but that's inside the square root. So the highest powers are really like x squared, but you have a square root, and that's like x, right? Of course, if x is negative, then this is really like negative x, but we don't care. We just want to know the power. We're not interested in the coefficient. This is like x because square root and square cancel, so you have x. So what we're going to do is we're going to divide the top and bottom by x. So we get limit x going to infinity. 4x divided by x is 4. 25 divided by x is 25 over x over square root of x squared plus 4x divided by x plus square root of x squared plus 25 divided by x. Now what is this? Well, you can, let's try to figure that out. You can take this part and make the denominator look like square root of x squared, so that you can put into single square root as this. Then you can take these two fractions apart and you end up with x squared divided by x squared, which is 1, and 4x divided by x squared, that's 4 over x, right? And we can do the same thing to this, and that's going to be 1 plus 25 over x squared. Let's do that anyways. X squared plus 25 over x. When you pull this inside the square root, it's going to turn into x squared. So x squared divided by x squared is 1. 25 divided by x squared is 25 over x squared. Okay, so that means this thing is limit as x going to infinity of 4 minus 25 over x divided by square root of 1 plus 4 over x plus square root 1 plus 25 over x. And as x goes to infinity, these will all be 0, so you end up with 4 divided by square root of 1 plus square root of 1. After deleting all these, because those are zeros, you end up with 4 over 2, which is equal to 2. Right, that was a hard example.